The objective of this presentation is to demonstrate how to promote or to showcase the failure mode analysis in front of prospect or customer if you want to do it. So the starting point, I don't start from scratch. I have an existing circuit, really basic, that can be done during the first presentation of how to draw a circuit in Automation Studio. In this example, the only thing I have changed are displayed onto the diagram. I have added on the cylinder a mass and an inclination just in order to build pressure automatically. If not, there is no pressure. It's difficult to try to detect failure mode without any pressure. The other thing is I have downsized the display, the default displacement of the pump just in order to slow down the extension and retraction of the cylinder. So compared to a basic demo, I have added these two proximity sensor because I will need them to determine the termination and activation condition of an operational mode. So I will do a very simplified analyze just on one function. So this system has been drawn with the Fmeca technology template, but you can use the template you want. The thing that must be known is that the functional group by default in this template, there is two functional groups. I didn't change nothing on this, so it means as soon as I have drawn by drag and drop my circuit and connect with line, all the components belong to the circuit installation 1.1. We don't need for quick demo to manage all the functional group. So by default in this project, I have two type of circuit, 1.1 and 1.2, but I will use only the 1.1. So the first thing to declare is the function. So the function in this system, a function is an actuation. So the cylinder will be my function. So I will create a function by opening this dialog. By default, it was an empty project, so no function exists. I just have to hit here to add a function. I will give a name of this function. So I call it actuator cylinder. It's really simplified. Cylinder. And now I have to declare to this function what components participate to this function. So in this example, all the components participate. As I mentioned at the beginning, all the components are located on this circuit installation. So I just have to select this circuit installation. This is done to specify the function. Now, I'm gonna create for this function the different operational mode. So there is two operational mode if we have a look on this circuit, the extension and the retraction of the cylinder. For the demo, I will just focus on one operational mode. So to create operational mode, I open this operational mode manager. You can see by default the function cylinder appear, and this is a toolbar to create by a new operational mode. So I just create a new. You see some tabs that are added, and for this tab, I will inform this operational mode. The first thing is that the operational mode is not assigned to a function. So the first thing to do is, okay, I will name it first, so extension. Now I will select to what function it is belonging. And you can give a description, a comment, and here you have a checkbox. Why I have a checkbox? It is finally these attributes. When I hit here, you see it is gray here. When I click here, it is selected. It is these attributes just tell the user that if you hit this function, the performance for this operational mode extension will be taken into consideration because I have selected it here and it is green here. So, but before doing this, I have to define the activation condition. So if my operational mode is the extension, we can consider that the activation condition of this operational mode will be obtained as soon as A0 will be false. Because if I start my simulation, of course, A0 is true and A1 is false. So I will just click on this tab, go into my variable available here. I'm selecting the alias A1, so I have two A1 and A0. So I will say select A0, but this currently means A0 is true, but the condition is A0 is not true. So in this sense, I have to add not this variable. So this means not A0, while the termination condition will be A1 true. So I just have to select my variable A1, and this syntax means A1 is true. So now I am ready to launch the measurement of the performance of this system. So if I start my function here, automatically I will have a message, because if you remember, the performance are measured only if you have dynamic measuring instrument on components that participate to the function. If not, look what's happened. It starts stop. I have a message, I display, and it tells me that there is no dynamic measuring instrument. So I will add a component dynamic measuring instrument from the simulation tab, and I will select, for example, this one. I can select also, just for to test, I can select also the power. I guess I have this function. Yes, output power of this motor engine. If I use those dynamic measuring instruments, you will see after I launch this feature, this measuring instrument won't be taken into consideration because it does not belong to a component, it belongs to a connector. Now I am ready, so I will launch this to measure automatically the performance. So currently the activation condition is not true, so I will activate this, and as soon as I reach here, it will be terminated. That's it. And now we see that we have a modification on the operational mode, and on the tab we see that the performance has been written. So we see two types of performance. The one that measures the linear speed. By default, each measuring instrument has a default value. For example, for the speed measurement, we measure the average and we give an approximate value, meaning the simulator has measured this average with a default percentage of error that is 1%. This is hard-coded. You can define, when you want to modify this performance, you can modify this percentage. For example, I will put 5% and I will round it to 10.5 centimeter per second. As mentioned, this unit is interpreted. If you want to speak in inches per second, you can modify with the good translation, because we are I think pouce is okay, but I think inch is okay also. Yes, you need to know not the translation, but the name of the performance. But be careful, if I change the unit, I have to change the value. And we have the performance regarding the power consumption. So we give the value of the consumption, and during this operation mode, we have a constant value, so the minimum equal the maximum. So let's figure it is my performance. I have many ways to change this expression. For example, I can use the timing. I can specify that this timing will be, the extension will be between 2 and 5 seconds, for example. So I can adjust, but I want to go quickly. Now, let's figure it is my performance. So if my performance is below this, with this percentage, I will be wrong. I will lose performance. So what can I do? I can specify the local effect. So to do this, I just have to explain the local effect, because this text will be used in the report to automatically fill local effect column of the report. So speed is not as required, and maybe you can specify the value you want. So for example, minus 10%, so maybe it will be between 9.5 and maybe 11 centimeter per second. So of course you have to make an accurate equivalence between this and this, but for the demo we can go in this way. So now I'm gonna save this, and I am ready to conduct an analysis. To do so, what I have to do, I have to declare some failure in components. So I have already done in some direction. So in the directional valve, I have declare, not activate. This is the role of the simulator to do this. So I have declared this. That means the variable exists. So by default, I use the default value of the parameter. You don't have to think about modifying this, even if it is in the way to define a small, big, or medium leak. I have done the same thing for high damping coefficient. There is a friction during the motion of the piston and rod inside the cylinder. I keep the same value, and the same remark, same value for this. Now I can open the failure mode manager, and I can see what exists in my system. So I have the data analysis. This is a report. So this is the output for the moment. As it is a project starting from scratch, there is no data, of course. If I go into data analysis, I can display the system according to functional group. So we have electrical circuit, we have fluid circuit, installation 1, circuit 2. Normally, on electrical, if I select electrical, I have no failure that belong to electrical component, because I have no electric diagram, neither electric circuit. On the circuit installation 2, nothing. But as all my components are here, I see by default the parameter. So in this dialog, you can visit. It's more identification of the component failure mode. Okay. And during the analyze, I want to see. So I can select the analyze I want to conduct. So if I put false, this component failure mode won't be taken into consideration. Okay. Sorry. One thing I have to mention now is to parameterize this analyze. So, for example, if we have a look, I guess the extension is less than 15 seconds. So what I'm gonna do, I'm gonna maybe declare 20 seconds, the timeout is used when the termination condition is not reached for any reason, because there is an external leak and so on. So we can put this timeout for the complete sequence. If my sequence was very big, for example, 2, 3, 4, 5 minutes, I have to put a bigger timeout. But if I do this, eventually it could be interesting in the operational mode description, the termination condition, to put a local timeout. If need be, just ask me if you want to know why, but it is just to avoid to wait this big timeout. I will select automatic mode and I will replace the data if a report already exists. So I will keep this value as it is. Now I will put start condition. So as it is a simple circuit, I mean the sequence is only this operational mode, I will keep the same parameter for start condition and end condition. So now I am able to launch my analyze. I keep the focus on this just to follow on this dialog, just to follow what's happened during the analysis. So I start here. The simulation tells us, display this dialog to tell us we are testing the first failure. So as I have forced my directional valve, already I restart, and as soon as I reach the termination, you see the sequence ended and all the failure mode is activated one by one. The look and feel of the icon show us that the 3 failure modes trigger system failure. So it means in the report we will have system failures. And you can see that we have 5 system failure modes. And some are redundant because I have in my operational mode, I have 2 performances. So just to simplify, I will restart with only 1 performance. And I will delete everything just to redo the analyzer, just to not mix you. There is an explanation, but it is not, I would say, interesting to have it in a quick demo. So I restart again, and you will see, so automatically the failure will occur. So the measurement, we see the speed, we can have a look quickly visually on one actuator that we have loss of performance. Not here, but in this one, maybe we have a low speed. Yes, it's lower than 9.5, I guess, or something like this. And now we have 2 failure modes. So just to return, here, this one is running. This failure mode does not affect the system performance. If you remember, I have all the failure with the power. It means the performance of the power has changed with this failure. But now we have only the testing of the speed, and this speed is not affected by this high damping coefficient. And in our report, we see that we have 2 new failure modes. We can see the fail component, we can see the component failure mode, so internal leak, and we see also the local effect. The local effect, remember, it is the text I have written by myself to allow the simulator to use this information to populate my report automatically. And here you have the detection mode. The detection mode is the dynamic measuring instrument that propagates its value to the component. And we see the comparison between the speed here and the speed recommended. The same here. So now the empty cells must be filled by the expert, because all this data addressing mitigation, potential cause. The potential cause of this internal leak, we don't know. We don't know the technology of the component. So only experts are able to complete this. The global effect, it depends of the system, where it is used, the context of use. It has to be explained by the expert. And the same for all the parameters. So when you launch now 100 failure modes, component failure mode, you will get many system failure that you can populate, fill, inform, and after this you can use this report when the field is calling the office to tell that there is symptom, and you can create filters and so on to feedback the field with a sub-report of this big report. So currently there is only 2 system failure modes. But this is a quick way to demonstrate this module. And as you can see, normally when you do demonstration of Automation Studio, you have to draw this type of circuit. So you can reuse it easily to demonstrate system failure mode. And that's it for the moment. Thank you.